Hi there. Welcome to Computing Foundations. This is a channel for beginners who want to learn about computers, programming, and the math, science, and art of electrical computation. I'm Josh, a retired software engineer. I designed and wrote software for 20 years, and I'm really fascinated by computers. I want to help give you an appreciation for this world-changing field of knowledge. Today we're learning to program in the C language, and our focus is going to be input and output. Now, you're probably very used to using computer programs like everybody. You've used them on your mobile phone and on your desktop or laptop computer. And most of the applications we use today have what are called graphical user interfaces, where you use your mouse and your keyboard to enter information and move sliders. All this is great, but today we're going to be focusing on a different kind of input and output, and that's what happens in a command line program or a console app, where you're interacting with the computer on a blank screen and the computer is outputting words and letters and numbers, and you can interact with it by entering words and letters and numbers. A lot of the programs that we're going to do for practice and for learning are going to use this kind of input and output. So it's important that we master this basic part of writing a C program. The C programming language provides input and output tools for you in what's called the standard I/O library. The standard STD input-output I/O library. The C language is made up of several libraries. I think there's 10 or 15 primary standard libraries that are included in the language. Basically, these are just pieces of software code that have already been written, and you can take advantage of them and include them in your programs, and by the result, you can have certain tools at your fingertips to use, like tools for input and output. All right, so let's start with output. You've already seen examples of this kind of output. Let me just really quick pull open some code for you and show you this on line 39. Actually, that's a bad example. Let me give you a simpler example. This on line 12, this is something from our last program that we looked at, the constants program. On line 12, we see printf, quotation mark, price, colon, %, the letter F, \n, and a closing quotation. Okay, this is the printf function. It's describing to the C program that you want to print something to the screen, and it's giving instructions on how to print it to the screen. So let's learn a little more about how this function works. So the signature of the function is that it returns an integer. The name of the function is printf, and it takes as its argument a character array. We haven't talked a lot about this data type yet. We'll talk about it more in the future. Basically, this just means a sequence of characters, and we enter those in as what's called a string, a sequence of characters inside quotation marks. This sequence of characters in this function is called a format string, and it includes characters that you want the computer to print out to the screen, like hello, goodbye, whatever you want the computer to print out on the screen, and then also format specifiers, which describe something that you want the computer to read out of memory and write onto the screen. And we're describing to the computer how to do that, how to read something out of memory and write it to the screen. So some really simple format specifiers are %i, hey, print an integer to the screen. %f, do a floating point number to the screen, and %c, do just one character to the screen. After the format string, we actually specify where we want the computer to get this value from. Let's go back to the code. So right here in this example, we're saying the price variable has a value in it, and we want the computer to print out that price variable as a floating point number. And we're telling it, place the number in this spot in the string. So first, print out price, colon, then there's a spot we've reserved for you to put the price, whatever the value of the price that's in memory, put that in that location, and then print all of that out to the screen. Okay, so these are the simple format specifiers, but we can have a much more complex format specifier. Every format specifier begins with a %, and it ends with the specifier. I've given you the 3 most common specifiers here. I for integer, F for floating point, C for character. But what about these other possible things that you can include in the format string? We're going to talk about width, precision, and flags. We're going to ignore this length specifier because it's a little complicated, and honestly, you're probably never going to use it. All right, so let's take a look at width and precision. So width and precision is telling the computer when they print out the variable that you've provided, how many total numbers should be printed to the screen. If the value of your variable has less than that number of spaces, the computer will pad the number of characters that you specify in the width. I'll show you an example of this in a minute. So if you put in a width of 4, the computer is going to print out a space, a 1, a point, 1, 0. So it would just always make sure four locations get printed out, 4 characters get printed out. And if it doesn't need 4 characters to represent your number, it will pad the beginning of the number with spaces. The second concept that you can specify, which you specify by putting a decimal place and then a number, the second thing you can specify is precision. Precision says, how many numbers do I want to appear after the decimal place in a floating point number? By default, the computer's always going to print 6 spaces, 6 characters after the decimal place. You can change that. For instance, if you're representing money, you probably only want to print 2. So you just say 2 in the precision. Now, one thing to note about the width quickly before I move on, the width never shortens the number. If your number has 6 digits in it and you specify a width of 4, the computer's just going to print all 6 digits and ignore your request. So the entire number always gets printed out. It's just the width will tell the computer to sort of pad everything. So a couple important flags which can be presented before the width and the precision is the negative flag, which means left justify everything. The 0 flag, which means pad with zeros instead of padding with spaces. And then lastly, the plus sign, which means if it's a number, always show a plus or a minus to indicate whether it's positive or negative. The default is the computer will only print the negative sign if your number in your variable happens to be negative. All right, so let's finalize this with a couple examples. What does it look like when I left justify? Okay, so if I did a format string like this, %, the negative sign, 4i. I'm saying I want you to print 4 characters no matter what. I'm giving you an integer, and I want you to, this negative means left justify. So if I asked it to print out the number 1, it would print like this, a 1, and then there's 3 spaces after the 1 that will be output onto the screen. 21 will be 2, 1, and 2 spaces will get printed. 321, 321, and a space will be printed. 4,321, all 4 digits, the spaces allotted are completely used up by the number. And if I had a number that was greater than 4 digits, it would just go ahead and flow that last digit off to the end. Okay? Right justify. Here's an example. %0 for I. I'm saying I want 4 characters to be printed. This is going to be right justified by default because I did not include the negative. And I am giving you an integer. So here's what it's going to look like. If I give it the number 1, it's going to print 0001. If I give it the number 21, 0021. You get the idea. But you can see here how the 4 in both of these format strings is making it so that the width of what's being printed out is always 4 characters, no matter what the number. However, if the number exceeds 4 characters, again, the computer will ignore it. All right, let's move on to the second function of the standard I/O library that's really important, and it's going to allow us to do input. This is the ScanF function. Similarly, it receives a string of characters as a format string, and it returns an integer, which I don't think I mentioned this for printf, but the integer will tell you how many characters actually got read in from the screen. In printf, it tells you how many characters actually got printed out to the screen, in case you want to know exactly how many characters were printed out. Because as we said, it doesn't always obey your format string. For instance, if your number is longer than the width you specified, it's going to ignore your width and it will still print out all the characters. So by looking at the return value, you'll know if it had to ignore your format string. All right, simple format specifiers for ScanF are %i, %f, %c, exactly the same as ScanF. When you put a %i, you're saying read an integer from the input and keep reading an integer until you encounter a white space. What is a white space? A white space is a space, a return, or a tab. All 3 of those things on your keyboard are white space. So %i says read from the screen or read from the keyboard, whatever the user is typing in, until you get a white space. Okay? %f is the same thing, read a floating point number. %c, read 1 character from the screen. Now, what's interesting about ScanF is you need to provide it with a variable where it will store the value it read from the screen, that it read from the keyboard. So here I define a variable called age. I set it to 0. And then in the next line, I write ScanF. I use the format string %i. And then this is new for you. I put an ampersand before the name of the variable age. What that ampersand means, and we'll learn more of this in the future, is you're telling the computer that the function scanf is allowed, it has permission to change the value in the variable age. In order to give a function permission to change one of the variables that you provide it as an argument, you need to have this % in front of the variable. It means the variable can be changed. And we'll learn more about this in the future. All right. Any character that appears in the format string before the % is simply matched, read, and ignored. So if you wrote in the format string, my name is Josh, what is my first initial, and then put a % and an I, the program would be looking to read from the keyboard that the user typed, my name is Josh, what is my first initial? And then after all of those characters have been read and matched to the string, now it will read in the next character that is typed on the screen and put it into the variable you specify. So you don't see this used a lot, but you can certainly ask the computer to read specific characters. All right, there is a special case here. White space is itself a character. So if you're asking the computer to read in a character, any white space, any spaces, tabs, or returns that are entered by the user will be read, and the computer will assume, okay, that's the character that you wanted to read. You wanted to read the white space character. So a space, a tab, or a return are white space. Now, if you just precede your % in the format string with a space, you're telling the computer you can ignore all white space that gets entered in until a single non-white space character is encountered. That's what I want you to read in and store in my variable. Ignore the white space. So look at the example. ScanF, and then I've underlined it here to make it super clear, a space %C. Then I put in ampersand and the variable initial. So I'm saying read in a single non-white space character. This will cause all white space to be ignored. All right, that's all I wanted to go over. You're gonna review now the program number 5 called input output. Program number 5 has lots of good examples of how to read in and then read in numbers, do an operation, and print out an output. So we're basically building a really simple addition calculator. You can run the program and the user will be allowed to enter in 2 numbers. The program will add those numbers and then print the result to the screen. So study that program. Feel free to goof around with it, change some of the format strings, play around a little bit, and see what you can learn. One last thing I'll tell you is online, I don't have it in front of me. I won't be able to show you. But online, if you just search for C language standard IO, stdio, there's lots of references online that explain to you all the different format strings you can create in a printf and a scanf function. You don't need to memorize all of it, but you do need to know these really basic format specifiers: I for integer, F for floating point, C for character, and that's going to get you a long way. All right, thanks for coming today, and we'll see you next time.